This is actually a little pre-seed talk on the 67-ton gun at Penlee Battery, which was 13.5 inch in diameter. It's the largest breech loader of its time and the only one done in the area. Now, the gun originally came down from Woolwich by barge to Penlee steps. On the steps would have been large shear legs to lift it from the barge onto each of the steps and gradually up the steps and shifted the shear legs as you go. The main thing is, on the barrel there are no trunnions to get in the way. It is effectively a large long tube, not as you would expect an old-fashioned cannon with bits sticking out the side. So you would have lifted this up, and then when you get to the slope at the top, put on wooden carriages, normally 4 or 6 wheeled carriages with big screw brakes. Attached then is a team of mules, horses, men and everything else to pull it up the slope and up to the battery. So if ever you've walked out there, just stand at the bottom where the roadway is and look up. That's where you're going to go, right to the top. Of these defences, the barrel itself is 67 tons, but you also have shield segments that sat around the gun so that the gun was protected. To fire at this gun from seaward, you wouldn't have seen it because it disappears. So they would have had to try and use plunging shot, firing a high angle up in the air from the ships to come down on top of the gun. So the shields were set around the pit so that the barrel came up through the shield to fire. So you have a shield segment on the drawing, and the barrel comes in its unload to its elevated 5 degrees down to 15 degrees up to be fired. And then as it fires, it disappears down inside the pit behind the shield.
Can you show me on your hands, John, how that works, please?
So basically, you have a shield curved section. The gun pops up and fires and comes down. So the only thing that you actually see on the top is the barrel in the middle and the shield on either side. And the whole lot revolved. So that no matter where you wanted to go, you brought it round, up comes the barrel, fires, disappears down underneath the mount.
So as the gun rotated, the shield went
with it. It would take the whole lot.
The shield was on wheels of some sort.
The whole thing was on wheels, so you'd have had a large traversing gear motor, all hydraulically operated, to shift everything around.
So this is because they thought the enemy fire would come from above, from a high angle gun at sea, when it would have come down plunging vertically
down onto it. That's why you have to protect this way. You can't see the front of the gun if you stand up there. If you went from anywhere, say you were a mile out to sea, if you looked, you can't see the top of the crest line. That's the whole idea. It's masked. So the only time you see it is when it pops up.
So how easy would it have been, or how hard would it have been to shoot this gun from sea?
Virtually impossible. You got to roll on a ship of anything greater than a degree, you would be missing your target by hundreds and hundreds of yards.
But as the gun used gunpowder, and it used a huge amount of gunpowder, I think it was up to 900 pounds of gunpowder, wouldn't have that made a huge smoke and the enemy ship could have aimed at that?
Right. The only time you'd have actually seen that smoke, in effect, was the moment the gun fired. Because you're on top of a hill, the gun in itself pops down, it disappears, so you can't see the gun. The smoke at the top of the hill would have been dissipated very quickly.
By the wind?
By the wind, because all hillsides have got an inherent upslope of wind or downslope. So as soon as it's gone bang, the smoke dissipates and drifts.
And that's why they go hang gliding at Whitsands.
Hence why you go, because you've got a lovely updraft.
So it would have been a very difficult task to hit this gun from sea.
Very, very difficult. You wouldn't have.
And of course, we didn't have aircraft in those days.
No. No.
So tell me, how did the actual gun operate then? And how heavy was it, by the way?
The barrel itself is 67 tons.
And how wide is the gun? Is it 13.5 inches?
13.5 inches in diameter is the size of the shell.
So how heavy would that shell be?
And here we go. I can actually, hopefully, if I can find my little bit of paper. It's terrible, this 67 ton. There we are. This is from the Naval Military Write-Up. The 67-ton breech loader gun, which is to be mounted at Penlee, near Folly Tower, has recently arrived at Devonport from Woolwich. So yeah, towed by barge from Woolwich to Devonport, and Devonport then back out. A valuable addition to the defences. Cost of the weapon was £12,000. £50,000 in addition will be expended for this mounting in the new fort. So that's the price of that.
And the shell was £1,200
in weight.
That's like throwing a car at it.
And the powder charge being £450 of powder. And it then notes it will be worked by hydraulic machinery placed some 60 feet below ground level.
Now tell me about
the gun,
John, because a lot of interest is in this accumulator pit. And as a young lad, I was lucky enough to, as you were as also, to actually look over and see the depths of this huge great pit in the middle of Penlee. And as we recall, it was enormously deep.
That's right.
So how did it all work, please?
Basically, I've done a little sketch. You have a accumulator pit, which is filled in the lower half with oil.
So a pit is a concrete hole in the ground,
Big.
like a lift shaft.
Yeah. It's probably going to be steel lined.
And how deep is it, John?
It's 60 feet down.
That's very deep.
The piston diameter is 20 feet. And on top of the piston is 70 tons of scrap iron. I know because, again, in the records we've actually got it written. Now, that is your accumulator, your store.
Of energy.
Store of energy. So before you start, you disregard everything else off, and you say you have a steam-driven pump.
So there would have been a supply of coal.
You needed coal, water, boiler house.
And someone to stoke the boiler.
Someone to stoke the boiler, fire it up, to run this little hydraulic pump, to pump oil into the bottom of the accumulator, and actually start lifting the piston up.
Would that have been a slow event, you think?
I reckon it's going to take you the best part of a day to lift that. Right. Now you come to the funny bit in the middle.
John, one thing, once the energy was stored, would it have stayed in there for like a long time? Would you have to keep topping it up?
You would have probably had to top. There would be leaks in different places. Don't forget, back then metallurgy, pipe valves and everything was all in their infancy.
Of course.
This is one of the first major innovations.
So it's the energy, and this gets lifted up over a period of, we don't know quite, a very long time.
Very long time.
Yes.
Lifts up. So you've then got this potential of stored oil pressure. Okay, so then looking at it, I've drawn it. This is an electrical base because I used to be instruments. That's the drawing of a diode. Now, a diode will allow the fluid pressure to flow in that direction, but not that.
Right.
Okay, so above us we have the gun, which is here. We can see on the drawing is various hydraulic pipes in underneath.
Yes, you can see them, can't you?
The main mounting. And a man possibly operating something on a hand wheel. Right, so I want to load the gun. So the breech gets opened. Now again on the drawing, if we look, here is a 3-lift piston. Smaller, medium, large. So that's hydraulically driven. There's the shell. The shell comes from the store and is lifted up into place to meet the back of the breech. A rammer then would come in and push the shell into the breech. Right, that's the first bit. So you've got a rammer and a shell lift. Now these are the valves that operate them, and they're taking pressure off the accumulator. You then need to put the powder charge in. You've got 450 pounds of powder.
That's the half charge though, isn't it?
You're not going to pick it up and drop it on. So what do? You have a powder lift, very much like the shell lift. Powder comes in, up. You then have to ram it again to push it in. The breech gets closed. You're then ready. Right, I want to lift the gun. Now, I have a little bypass valve around the check valve. I open that, allows the fluid pressure to come in, around the check valve, up and into the actual piston at the bottom of the gun. So that will then push the barrel physically up. You're using the reverse of the normal control of a gun. When a gun you fire, the recoil comes back. You need something to control the recoil, so you have a hydraulic buffer. In what we're doing this time is the hydraulic buffer is actually being used to push up. So we're up. We then have another set of check valves coming off, because somewhere out in the distance the men are there with their range finders looking at range. You need to know the height of the tide. You already know the height of the position finding cells, both at Crowston Field and Folly Tower.
That's left and right of the battery.
Left and right, about 400 yards on either side. Normal, what you would expect. You can then do simple trigonometry. You know the distance from the gun to each. You know the distance between them. You know the angle down. You know the bearing. So into all this information goes in on a mechanical plotter. The mechanical plotter then gives you a solution.
An analog computer.
Basically, yeah. You dial in the height of the tide. You dial in the angle. And it tells you at that certain range, at certain elevation, fire. Now, somewhere in one of the rooms, there would have been a man of a gun operation room. He would say, right, fire, push the button, electrically fired. Off the shell went. Now, once the shell had gone, the recoil throws the gun back down into the pit. Now, in doing so, you're using the piston that you used to elevate to return pressure. So the pressure then comes back into the piston, back down, through a one-way check valve, and into the accumulator. So it tops the accumulator up with the expenditure of the recoil. So you're using the recoil to give you a reserve, and then the whole lot can start again.
So this gun couldn't be used at a moment's notice, could it?
Oh no, you would have had to make sure you have sufficient pressure. It's got to be manned everywhere, not only at the battery. The observers have got to be manned. The height of the tide has to come up. So yeah, you would have involved quite a few men. It's a bit like a pyramid. The final thing of firing the gun is at the top of the pyramid, but you've got all these ants running around underneath, making sure all the information's fed in.
Now, we also know the gun was only fired once.
Yes.
Why was that?
They test fired the gun with half charge. So you'd have had a normal shell. So yeah, 1,200 pounds of shell.
And the main charge was 900.
Yeah.
So half a charge.
Half a charge.
450 pound of gunpowder.
Yep. Now this probably was P2 pebble powder. Looks a bit like Smarties. This was way before the event of cordites and things like that. So it was a good thing. You can put your hand in it and scoop it all around. They're polished grains. Looks like Smarties.
And that's so it doesn't burn too fast, isn't it?
You need a nice steady burning powder.
For a nice push of the shell at the barrel.
What you've got to get is when you fire here, by the time the shell leaves the bore, you must have burnt all your powder up in accelerating the shell. If you don't have enough, it starts to slow down before it's leaving the barrel because your pressure drops. If you get it the other way and too much, as the shell comes out, you'll get a horrendous flash of burning powder still going off.
Outside the front
as soon as it,
that flash will set fire to the environment and possibly the
that's right.
staff. And
give you a huge, great ball of flame.
So this worked. They fired it the first time.
Yeah.
It went bang.
It went bang,
and
yes.
Then
it knocked all the, according to the report, it knocked all the machinery out of gear. Now, from that, if you look at the dates of what we're doing and the metallurgy at the time, I would very strongly suggest that the recuperation rate of the gun recoiling had so much pressure in it that it smashed the valves.
Because the technology
was
not there.
You would have had old cast iron valves. So they would have had a cast iron valve that took you to, say, 300 psi. But the instant this thing fires, you're going to be looking at 1,000, 2,000 pounds per square inch.
This weapon really was pushing the boat out, the limit of technology
really.
at the time.
It was the biggest 13.5 breech loader we had, going to the biggest range distance you could have. It was technology at the limit.
So what happened to the gun after this rather unsuccessful operation?
Well,
this is the question, isn't it?
In the paper, everything suddenly goes stum. There is nothing ever written about it that I have ever found in all my proceedings.
So as we say, and then,
if you look a bit further, the whole lot was dismantled because they couldn't improve the metallurgy. They couldn't do anything else with it. It's the only one they've got in Britain. Oh dear, we've done a cock up here, lads. What do? Hide the damn thing. Well, you've got a 67-ton barrel. You've got big shielded sections weighing 15 tons each. What do? Well, look, my way of looking at it is there's a big ditch that runs around the outside of the battery. Roll it over. Because the gun has got no trunnions, it'll roll quite easily. Dig a shallow ditch down there. Come on, right, I want a 20-foot, 30-foot long ditch. I want it 15-foot square. Roll the barrel down, drop it in, drop the other stuff, cover it over the top.
And forget it.
Because the next thing that pops up is there's a proposal to put a new 9.2-inch gun in the 13.5-inch pit.
John, that was a fantastic piece of history. Thank you very much.
No problem, Steve. Thanks.